All right, guys, go on YouTube and let's start immediately since we have a lot to cover. I don't have network. Oh, maybe my VPN. Are we ready? Guys, jump in. Let's start. Oh, 51 is outside. Laundry, please, from next week, make sure you don't miss any class because next week we start accelerating with the exam proper, only the exam. Okay? Please, next week, make sure you don't, and they are not recorded. Make sure you don't miss sessions from next week. Please, and if you have interest on the exam, please make sure that you let me know before Wednesday. Those of you that did let me know already, you know yourselves. You know yourselves already. And if you want to join them, or if you have that intention of doing the exam, you make sure you let me know before Wednesday because I need to create an environment for each person that's joining. And it's not like a day's job just to create it. Okay. Rafa, are you okay today? Yesterday you were so tired.
Yes, sir. Thank you.
Okay. If by God's grace we finish and have time today, I'll introduce containerization to some of you, or to a lot of you. I think we'll give a medal to the most distracted person always in this class. You guys should prepare a medal for Jocelyn. Always the most distracted person. Okay, let me share my screen. All right, last week we saw Can you guys see my screen? Great. Concentrate, guys. Last week, we saw storage where you add your hard disk. The first step, where the first step is adding your physical drive or your drive that you have. But of course, on a virtual environment or on your hypervisor, on your virtual box, you just go to add and add storage, right? You go to add and add the storage. You add the storage, and now your server, the second step is the step where your server starts seeing that storage, right? Your server starts listing that storage, maybe as SD something, SDB or SDC, SDD, and it's telling you that maybe it's 2 gigs or it's 20 gigs, right? And the third step is when we initialized the disk, right? Using what? Fdisk. We use fdisk to initialize the disk and create a partition. And the fourth step was actually mounting that disk, creating a file system, right? Creating a file system on that disk. We do fdisk to initialize to init, to initialize the disk. The fourth step was making a file system, make fs, making that disk in a file system. And the fifth step was what? Mounting it to a directory, right? Mounting it to a created directory, maybe /new disk, /new disk. This is what we explained. So let me see. All right. So we said the first step was actually having that physical disk added, maybe using your virtual box or VMware if you're using VMware. Alex, please, if someone is in the chat, please add that person. Okay. If someone is outside, sorry, if someone is in the waiting room, add that person. Okay. All right, well, so you add the disk, you see the physical disk, and you initialize the disk, you turn the disk into a file system, and you mount the disk, right? Those are all the steps. Then when you mount the disk, you do a df-h finally, you see the disk mounted, right? When you mount the disk and add it in your FS tab, right? You make a file system, add it into your FS tab. When you do df-h, you should be able to see the disk now. You should be able to utilize the disk at this level. Great. That's for a storage. Let me say that's for a storage mechanism that is traditional. We call this like a traditional storage, right? Traditional system. So you have a traditional approach. Because if you add a disk of 100 gigabyte, what if it's 100 gigabyte? You do fdisk, you're allocating all that 100 gigabyte. And even if you don't use that 100 gigabyte, the disk, you're wasting resources. Is that true? So a better way or a more standard way that a disk that we add disk still contains the first step where you have your disk, where you do have your disk, right? I still have my disk on step 1, right? Step 1, I still have my disk. Step 2, I still see my disk, right? Maybe it's SDB or SBB, anything. I still see my disks. Step 3, I still initialize my disk. If I want, this is now optional. This part is now optional, right? Step 3 is now F disk. This will be now optional because without that, the system is intelligent enough. If you're using, can you guys hear me well?
Yes.
Yes, sir. We can hear you.
Okay. All right. So this step, thank you guys. YouTube makes it really easy for us. So this step, is Thomas here? I don't think so. Okay. This step right here is now optional, right? It's now what? Optional. Now, after this step, what you do, it becomes interesting because you create something that we call a volume group. No, let me say you initialize it with physical volumes. You turn them into physical volumes. So you turn your disk, it can be one disk, you turn your disk into a physical volume. At this point, you're turning your disk back into a physical volume. But this physical volume, it's like you come here and you turn it back to this. So that because the mechanism that we want to use has its own way of labeling your disk. So we turn it into a physical volume, right? To tell it that this is the volume you're going to reuse. Because I can start here with one disk, come here and subdivide it into 2 disks, right? That's why I say this one is optional. If you like, you keep it as a single disk. If you like, you turn it into 2 different disks. Then you initialize it back into a physical volume. After initializing it back into a physical volume, what you do is you create a volume group. So this is PV. You create now what? A volume group. When you create a volume group, from that volume group, you can now draw a particular part. You can take a small portion and allocate it as LV, right? As a logical volume now. It's just logical because it's not actually the space is, all your storage is right here, but you're chipping just a little bit. You do this already at home. You do this at home. Some of you, when you need oil to cook, you don't have just the quantity that you want to cook with. You have a whole like volume group of oil. Let me call it a volume group of oil. Then if you want to cook your plantains, you subdivide it to like a logical amount because the plantain is going to know only that I need this amount of oil. That's all it knows. It doesn't know that you have a whole container of oil, right? So this is like a logical volume. So you buy your thing from the store, you put it on your shelf, then you allocate a small part for a different thing. You can allocate another part for a different thing. Well, now the question I want is, what happens? What happens if the oil is not enough? Can you respond, Jocelyn?
You just had hot
Where do you take the oil from that you are adding?
from the bottle.
Okay, from the volume group, right? From the bottom. It's the
Yeah.
same thing with space. So when you have your space this way, for example, when you have your space this way, let's say, Let me see. 1 second. All right. For example, this is like a volume group, right? Let's say this is a volume group right here, 5 terabytes. This is like my container. Okay, let's say this is 5 terabyte or 14 terabyte. I have used 9 terabyte of it, and I still have a lot of it left, right? I have like 5 terabyte of space left right here. Now, what happens is when a VM needs space, it will come and grab it on this volume group, right? It's the same concept. It's the same exact concept. So what we are saying is that when you make it now a volume group, once you make your volume group, now from the volume group, you can what? Allocate, you can make various logical volumes on that volume group. You can make various logical volumes, or you can make only one, your choice. You can make various logical volumes. Then after making the logical volumes, or let me just bring one of the logical volumes here and call it LV. You can make what? Logical volumes from this. After making your logical volumes, then you make it into a file system. Then the other steps now continue exactly the same. Is that understood? Now, what happens if this space gets filled up? You can just pull from the volume group. But on the traditional design, you mount everything, and if it fills up, there is nothing, let me say there's little or less you can do to actually increase the size of that space. No. But on what? On logical volume management, LVM. We call this logical volume management. Logical volume management. Logical volume management. It's very, very important that you know how to manage disk. Because if you're building an application, you need disk. You need to know that that application might grow in time. If you use this method, Alex, please, if someone is coming in, please take them in. I'm not sharing? Oh my God. Oh, no, I'm sharing. I'm sharing, right? Yeah.
Yes, you're sharing.
Oh, just that I saw it on YouTube. I wasn't seeing it, so. Is it coming out on YouTube?
Application
Yes.
might grow in time. Not sharing? Oh, no.
Okay. All right. So logical volume management, you manage storage using a logical division. So when you initialize your physical volume, you create a volume group from that physical volume. That means you can actually have 10 what? 10 physical drives pouring everything to what? Pouring everything to this volume group. And the volume group is growing in size. Then what happens is when you need space, you just extract it from the volume group. When you need space, if the volume group gets full, what do? You just add another disk and attach it to the volume group. Then the volume group will be growing continuously. Why? The logical volumes, if they need more space, they'll take it from the volume group. All right, let's see that in practice. Okay. Might use one of these servers. Do I have a server here? Okay. Let me use this server. I hope it's free 9. Let me use this server. Hope there's network on it. All right. Settings. Okay, it's connected. All right, so let me add a new hard disk space, right? Let me add a new hard disk space right here. You guys should watch. Nobody should be trying to do it. Concentrate and watch. So I add a new hard disk space right here. Hard disk. I want to add a hard disk. Right here, I make sure that I do a thin provision, not a thick provision. This is enterprise stuff, just adding thin provision. Thin provision and thick provision, what's the difference? Thick provision is actually faster than thin provision, but the thing is that with thick provision, all the disks is allocated at the same time. But within provision, what happens is it only takes what it needs, right? It only takes what it needs. For example, if the capacity, if it needs, this is not part of logical volume, this is just part of this software or how the software manages storage. So I want to keep it as thin provision. Let me add 10 gigabyte, 10 GB. So I've added like 10 GB of space. Let me see. All right, I've added like 10 GB of space, right? I added a 10 GB of space. Great. Now let me boot the server right here. I don't even know the root password. I hope it will automatically get a DHCP. I just want an IP, that's all I want. I don't like working from the console at all. Okay, NMTUI, edit the connection, edit automatic. Let me do an auto. I don't remove. Okay. IPA. Okay. This 172.12.161. One 172.12 dot no dot 16 or 16.12 dot 161. Great. Okay. I've logged in. Always try to work with the remote console. It's easier than working from the console itself, right? So sudo -i. Great. Let me make this a little bit, increase the size, increase the size, increase the size. Okay. Now, can you guys see my screen well? Okay. So I've added space, right? If I do LSBLK right here, you can see that I have an SDB here that's added, which is 10 gig, which is a space that we added. Now, let me see. I don't usually like this thing too much. Okay, great. You guys can see that I've added space. So I want us to go step by step, visualizing what we are doing also. So the first thing that we've done is we've added some space. Let's call that a 10 gigabyte hard drive that we've added, right? You and I know that we've added a 10 gigabyte hard drive, which is right here. Let's call this our 10G, our 10G space that we've added. Okay, we can actually see it in the system, right? We can actually see it in the system by doing LSBLK. That means the system recognizes our 10G already. We can see it, and the system named it what? SDB. The system can see it as what? 10G, and it has named it SDB. In the beginning, when we were adding it, did you see any SDB there? No, you did not see any SDB. I can go back and show you right here. So this is the disk we added. It was just hard disk, right? You can see that the name was just hard disk right here, 10 gig that we added. There was nothing else. Okay. So the system is seeing it as 10G, right? Before, now, the reason why I said step 3 is now optional, which is right here. Step 3 is optional. Now, I can divide this into SDB1, SDB2, and SDB3. Let me just do the division, not that you have to, okay? No, let me first go without the division. After, I'll show another one with a division. Okay, so I can have this as this. I don't need this, step 3, because in the traditional way, you needed to initialize the disk with fdisk. But since I want to use all the space, if I want to use all the space, if I want to just turn it straight from here to a physical volume, which is right here, I will just, the logical volume tool. Oh, I forgot something. Guys, give me 1 second. Let me pick this call. Can someone help send the link of the class to my phone? It's too much headache for me going to look for it. Let me see, Zoom. Oh, okay, it's okay. I have the link here. All right, let's continue. So I said this step right here is now optional, right? Because if I don't need to separate this disk into various disks, remember right here, we said we could separate the disks into various disks. I can separate this disks into like 1, 2, 3, 4, or like 2.5 gigs, like 3 of them. Use one for a traditional method, use another one for logical volume, logical volume management. That's why we can separate it here. But I don't want to do that, since I want to use the whole 10 gigs for what? For PV management, for logical volume management. So the logical management package that is installed is intelligent enough to know that if a disk is existing, like right here, this 10G, you do a PV create, it will give it a type LVM. So now, if I do fdisk-L to list the disks that we have, you see that SD right here, you see that we have SDB and we have SDA. And under SDA, we have SDA3, which is what? Linux type LVM right here. That is used for the logical volume management. It must be of a Linux type LVM. So now we have SDB, as you can see right here, and it doesn't have any partitions. It doesn't have any type. It's just a disk that's existing, and it's showing you the sectors of the disk. That's all we have, right? That's all we have. Now, since we don't want to initialize it, it's optional, so we don't want to do it. So let me clear my screen and go back up. Now I do a PV create. Since I do LSBLK and I see my disk right here, the name is SDB, right? So I do a PV create directly /dev/SDB right here. You see physical volume created /dev SDB successfully created. Now we have created what? We've created a physical volume that can be recognized by the logical volume package or software. It has a way of naming or dividing its own physical volume. We call it extent, but that's too that is taking you out of the lesson. So we've created what? A physical volume, an SDB in red, which is now a PV, a physical volume of the same size of 10 gigabyte. We can see it right here by doing PVS. PVS is PV show, PV display. You can use PV display also. You can see when you use PV display, you realize that there are two physical volumes right here. I want you to watch this attentively. See, there are two physical volumes right here, but only one of them has a volume group, which is SGA3, which is the one that you have used to build your rail system. Now, we have what? SDB. You see, it doesn't have anything. What's the type? LVM. Before it had no type, but now, just because you did PV create, it initialized it for you, and it gave you the type of LVM. And the physical size is 10 gigabyte. Free is what? 10 gigabyte. Those distracted. Okay. So we have the physical volume here, which I said the SDB. You saw it right here, right? This is it right here. We added it on VMware. The system showed it as 10 GB, 10 GB. We see it. Now we did a PV create, and the system is now showing it as 10 GB right here. Now, the most important part now is creating what? The pool, the volume group, which is the pool. We are creating now the pool, the volume group pool, so that any other logical volume can pull from it, right? It's like when you go to the store, you buy something, you buy oil. You go to the store, you buy oil. It's there. you come and put it somewhere in a container, and you add another one there, you add another one there, you're creating a pool, right? From where if you want to cook something, you can just extract a little bit and cook, extract a little bit and cook. If this one gets finished, you go and buy it and you come and replenish it. Exactly the same thing. Okay, so let's create the pool. Now, creating the pool, these commands are always the same. We are creating a VG, right? A VG pool. We are creating a logical volume pool, a VG pool. So what do? I do VG create, right? VG create. I can call it VG data, volume group data. This is a naming. I can call it volume group GIFTEC. I can call it volume group anything. If it's MySQL, I can say VG MySQL. If it's an Oracle database, I can say VG database or VG Oracle. VG, you can call it anything. If the application, maybe it's App Dynamics, you say VG AppD. So you can do a lot. You can name it as you want it. Let's name it LV data, right? LV data is what we want to name it. And /dev/what are we using? We are using the physical volume what? /dev/SDB. That's the physical volume that we are using. You can't create a volume group without using a physical volume. That's why this thing takes it. That's why the system takes your physical drive and turn it into a physical volume. Then you can create now a volume group on it. So VG create VG data, that's the name, with /dev/SDB created. Now, the volume group has been created. If we do PVS again, notice right here, there was no volume group for SDB. It was blank, completely blank. If we do PVS now, again, you can see now that VG data has been created on /dev/SDB. And the size is 10 gig. Now, well, what command do we use to check the volume group? Can you guys give me the command? Can you guys give me the command? Someone says I seem far from the mic. Can you guys give me the command? Great, VGS. You see, the commands are the same. PVS, VGS, LVS. So VGS right here shows me that I have a volume group now called VG data. VG data. And what's the size? VG data has size what? 10 gigabyte. And how much space is being used? 10 gigabyte. Oh, sorry. How many space is free? 10 gigabyte. VGREL, there's a volume group called VGREL, and it's 48 gigabyte, but 0 is free. That means my system has given all its space. Like 0 is free on this volume group right here. That means if something is coming to pull from this volume group, they can't pull anything because it's empty. It's full. Sorry, it's completely full. Unless I attach another disk right here and I'll grow this volume group. All right, ours is 10 gigs right now. If I do LVS, logical volume show, you can see that there are two logical volumes. One is swap and the other one is root rel, the root file system. And they are of size 44 gigabyte and 33.9. Do you see why there's no more space here? Because the logical volumes are taking everything. When I do LVS, you see root, swap, just as I said it, when you need it for a particular thing. So right here, when the rel volume group was created, the system needed to create the root file system, and it drew out part of it and called it root, right? The LVS. It did an LVM call root. It did another one called what? Called swap. This one was 3 gigs and this one was 46 gigs. That's how the system managed this thing. Now we are creating ours. Ours is VG data, right? VG data. Let's say we want to use a part of it for NFS and use a part of it for what? Mounting our repository, right? I can create now logical volumes from this. Now, let me create a logical volume. LV create, LV create, LV NFS. So LV create dash N for name. Dash N will stand for name. The name can be, how should we call it? How should we call it? LV NFS. Should we call it LV NFS? Hello? Okay, let's call it LV NFS. LV NFS. LV NFS. Okay. We call it LV NFS. Okay. And the next thing will be the size. Someone said LV dollar. Okay, what do you think should be the size if you've done LVMs before? What should we use to put the size? Dash what? Someone said dash S. Someone said dash F. Okay. Now, if you don't know, what do you do? If you do not know, what do you do? What is the best thing to do? Thank you, Jocelyn. Jocelyn says, if you don't know, do a man. Is that what we should do? Okay. Let's do man LV create. Great. This is the manual, right? Let me just say this is the manual where you can get the help. Help. It has a lot of things inside. But as I told you, you can always do a search. If I do a / and I put size right here, you can see everything with size. But there's one good thing in here called example. You can do example also in here. And you'll see examples, right? If I enter, I am in here. You can see various kind of examples, the way to use it, right? You can say LV create -I, you will see so many other kinds of examples. But I think they have very good examples. If you do this, let me see, sorry. If you do this, examples, let me see, examples. Sorry. What? Am I still in here? Okay, let me see. All right. Let me get back in. Except this version of rel does not have those examples. Okay. This version of rel, LV create -L. Okay. You see that -L here? It's showing me instead -L for size, right? Not -S. If I did not know that, now I can see it. It says -L 5G. LV create. Forget about the type. There are others here, right? LV create. I think there should be more in here. Yeah. So LV create, You can see this one says -n for name, -n for name, right? Then the volume group where you're picking the size, you're picking -L for what? For size. But also there is a -L also, which is a lowercase l, which I won't show you guys that now. Another way is you can say --size. If you don't know the options, you can use --size also. So this is the documentation that if you get stuck, you can actually check the documentation. Look for examples in the documentation. You can see. You can also say lowercase l, 100% free. This, I'll show you why they use this lowercase l in another, when we are doing another one. Okay, so we saw that if you use uppercase L, you can now like give the disk the size that you want. The name can appear in any order. You can see this can appear in any order. But you see, VG00 should be the volume group that you're pulling your stuff from. This is more advanced. But let's just go with this for now. When you master it, then you can do more. So if we call our LV create command again, capital L, what? Let's give it 9G. 9G. Where is the space coming from? You guys should tell me, where are we taking this space from? So we are creating our logical volume. Where is the space coming from? Someone said VG. Someone said PV. Wow. So we've created a VG right here and we can see it. We name it VG data. Great. So we named it VG data. If our space is coming from somewhere, when we did VGS right here, you saw something called VG data that has a 10 gigabyte. If our space is coming from VG, this system has only two, REL and VG data. REL has 0% free. VG data has 10 gigs space free. Now we want 9 gigs to use for our LVM called LVNFS, but it's good that we should use VG data. VG data right here, which is the volume group that we created. Now, when we enter, it says logical volume LVNFS created. Here, there were two. When we did LVS here, we had two LVMs right here. Now, if I do LVS again, you can see now that we have three LVMs. LVNFS is taking its space from VG data. LV swap is taking its space from REL. LV root is taking its space from VG root. Now, this is the size. And right now, since we've created what? We've created our LV. We've created our LV right here, which is called LVNFS. 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 Now we can proceed with what? The other steps, making it what? A file system. After making it a file system, what do? We mount it. So make fs, make file system.xfs. There's ext4 and there's xfs. ext4 is an older file system mechanism, right? And XFS is like a more newer one and a better mechanism. So they can tell you ext3 is even lower than this. They can tell you to create an XFS file system, an ext4 file system, maybe an ext3 file system. Maybe it's an old application that they want to install and it can only use ext3. So you have to make fs.ext3. You can also make fs.ext4. You can make fs.xfs. What are we making? From /dev, what? /dev mapper, what? VG LNFS. Right, this is the complete path of where everything in Linux is a file or a directory of where this is being stored. So this is the complete path. So I am making this logical volume into a file system, right? Right here. So when I press enter, you want to see like this, it's done, right? It has created a file system. File system might just be, what's a file system? A file system is just a way, or let me say, a table-like kind of way that data is being stored, right? That's what a file system is. I am creating like a table kind of way. For example, when you're you're opening a spreadsheet on what? On Microsoft Excel, right? There are various kinds of tables. Or if you want to do a table using Word, there are various type of tables. So XFS, maybe XFS might store data like this, and ext4 might store data in circles, and ext3 might store data in blocks. So it's just, that's what a file system is. You're creating a table where your data can be stored on various parts of those tables, okay? All right, so we've made our file system. We've given it a type of ext xfs, right? Now, if we do lsblk again, lsblk, remember the first lsblk that we did? There was nothing here, right? See this. You can take a picture of it to compare. Now, if we do LSBLK now, you see that it will also have subdivisions where you see that a VG was created, but it will not be mounted. You see that the disks, it will not more be disks, but it will be of type what? LVM. So if we do LSBLK now, notice the difference. Now you see, this is of type LVM now. VG data was created on it, and the LVNFS was created. And you notice now that it now has a type LVM right here, a type of LVM, and it's not mounted. Now I can just make directory. Now this part is easy. I can make directory /NFS share right here, anywhere in the system /NFS share, right? NFS share /NFS share. I've made my directory. Remember when we said what?
The screen is down.
My screen is down.
I mean, we can see the bottom of the screen. Yeah.
Oh,
So,
yeah. So I just made a directory /NFS share. That's all I did. Remember when we said the system always holds everything outside of the system, like in an external location till you want to like come in, right? Till you want to allow that thing to come in, then you need to mount it. So if I've created /NFS share, now if I do blkit block device ID, because it's always good to use the ID, the UUID of what? Of a particular disk to mount it. We created /dev mapper what? VG LVNFS. So we want to look for something that says /dev mapper what? VG data LVNFS. Remember, this is the path. This is what we did create. I copy the UUID, right? This is the UUID in here. What is inside here is called the UUID. It's telling me that the type is XFS. I copy this. Why am I copying this? because I need to put it in HFS tab as we did with the other storage. So I VI to /etc FS tab right here. And I add a new line. I do UUID equals to, I paste my own UUI, I just pasted it twice. All right. So I add a new line and I say UUID equals to, I paste my UUID, right? That's my UUID. Where did I mount it? /NFS share. Where do I want to mount this /NFS share? What's the file system type? XFS. Then I can do a default what? 0, 0. I save and go out. Now, when I save and go out, I just do df-ht to check. Let me clear my screen if it's there. df-ht, it's not there, right? You can't see /NFS share. You can see it. I'm only seeing /dev mapper rel root. I'm not seeing any other thing. Now, if I do a mount -a, comes out clean, and I do a df-ht. Can you see /dev mapper bg days, which is /NFS share right here? Can you guys see this? Now I can use it for any application. You can see that it's 9 gig and 8.9 gig is being used. Okay. So that's how you kind of create like a logical volume. Okay. That's how you kind of create like a logical volume. And now let's see what will happen if the logical volume gets filled up. That's one thing. Now, if it gets filled up, what happens? How do you continue? If it gets filled up, what do you do if it gets filled up? When it gets filled up, what do you do? I can't see you guys. You can add more space. Okay, great. So let's try to see if we can fill this up, right? Let's try to see if we can fill this up. Let me see if I'll be able to fill it up. If equals to /dev/0/dev/0/dev/0 of equals to /NFS share with byte size of equals to 9 megabyte. Let me see. All right, I just duplicated the tab because I added something here. I'm writing files. I don't even know the root password. Let me do a sudo dash I. Oh, okay. If I do df dash ht right here, oh, NFS share is not being filled. Yeah, let me see. Let me see. Yeah. Let me see. Now, did it if they fail to open slash NFS share directory? Okay. You can use Folkit. Let me try to use Folkit. Let me see. Let me try to use Folkit. Folkit dash L AG slash NFS share slash NFS share slash new file. Oh my God. Okay. Let me see. df-ht right here. Okay. Now you can see that the disk right here. You can interpret this, right? The disk is of type XFS. The size was 9 gig. Used before was 97 megabyte. Now used is 8.1 gig. Available was 8 gigabyte. Now available is 918 megabyte. Then the size is 91% full. If I create a second file of size, new file 2, let me say of size 900 M, and do a df-ht now. Let me clear my screen. Do a df-ht now. You can see that the space is completely full. It's 100% filled up. If there was any application on this drive is not more working. Like, if that application will shut down because it can't write new files. It cannot do anything, right? You can see that it's completely full up the 9 gigabyte. What is good with logical volume management is, since now you send me a ticket saying, hey, NFS share is full. Of course, you'll be monitoring this with Nagios. How can I monitor this with Nagios? I don't have Nagios here. I could show you how you can create a file system and just monitor it with Nagios. Maybe Ashley or who is the other person that has the Nagios up? If you have your Nagios up, after you can share your screen, we create an LVM and mount it. Then monitor it. Monitor that disk. Okay, so as easy as it is, right here, it's 100 gig. Right here, it's filled up. What do? I just say, wow, my disk is 100%. Like you can see it being 100%. Let me refresh my drawing stuff. So everything here is filled up 100%. Now I can say LVS. I can see that my LVS is 9 gigabyte. The size is coming from VG data. Well, I say if the size is coming from the volume group VG data, then I can check the volume group and see if there's still size there. VGS, right? VGS. I see that VG data has like free, it's like 1 gig. I have 1 gig free. Like, well, it's not up to a gig, but that's fine. but let me say I want to add at least 900 megabytes to this, right? Let me extend it quickly by 900 megabytes. What do? I just do LV extend, right? I can just do LV extend. I want to extend a logical volume. LV extend dash L, right? LV extend dash L. Let me say 900 M, 900 megabytes, right? What am I extending? I am extending /dev, remember, mapper, /dev mapper, let me see, /dev, yeah, /dev VG data, LFS, yeah, /dev VG data LVNFS. That's what I'm extending. Boom. It says good, new size given, 225 extents. I'll tell you what these extents are later. So not larger than existing size. Oh, new size given, not larger than existing size. Okay, great. This is a fatal error that I did. You do not do this. Always watch out for this error because you can do it without knowing. So what happened here is that if you LV extend a size of size 900 megabyte, you are just saying that twin down the 9 gigs to like 900 megabyte, turn back everything to 900 megabyte. So always make sure that you put a plus. I hope you see this error, because if you have 100 gigabyte and there's data on that 100 gigabyte, then you try to extend it at work. It's filled up, you want to extend it. You go and put a new size or extend it with 2 gigs. Maybe you have a terabyte of space, database is consuming a terabyte and it's filled up. You want to extend it and you do not put a plus. You just give that exact size. Now, plus 900 megabyte. You see, now it is created. Before it said, hey, the size that you're doing is not larger than this. That means the size, you're twinning down something, but already the one that exists in it is more than what you're twinning it down to. When you put the plus sign, you're saying I am adding. There's something called the just price or just the price. When you are saying that every extend dash L900, no matter what this thing is, just bring it to 900. When you put a plus, you're saying whatever this thing is, add 900 to it, 900 megabytes to it. If I do LVS right now, you see now that it's 9.88 gig. That means if we do our DF-HT now, what should happen? We should see this thing should no more be 100% consumed. Is that true? Is that true? Okay. As you can see, Alan, there's 9.88 megabytes here, 9.88. So now what I can do is if I do, let me clear my screen since you guys say you're not seeing it down here. If I do df-ht, oops, it's still 100 gigs. We know for sure that we don't have to create a file system again because the file system is already existing. We don't have to do make fs again because it's already existing. So what do we need to do? Even if we mount again, if I u-mount, let me u-mount / nfs share df-ht, it's gone. Let's mount it again. Mount -a, df-ht, still 100%. That theory doesn't work. What's the file system type? XFS, right? I do XFS underscore grow FS. I'm just telling the system that, hey, I've increased your size, so just grow. Make sure that you go back and read the table and increase the table size. XFS underscore grow XFS slash what? NFS share. It says, you see, the data blocks have changed. Remember, I told you that this thing, file systems are like a table kind of stuff. So you already told the system that you had 10 gigs. So you had this number of table lines. So the system gave those table lines and put data on it. Now you increase the table line, but you need to tell the system again that the table lines have increased, right? You need to tell the system that maybe the table lines have increased. So the system can now readjust and grow and expand. Now, if we clear our screen and do gf-ht, now you see it's back to 91 gigs. Now, if we do VGS, we can see that there's only 120 gigs left here. There's only 120 gigs left. 120 megabyte left on our volume group because LV, if I do LVS, this LVS is taking 9.88. Another way of seeing stuffs, you can do LV display, VG display, PV display. So LV display will show you all the logical volumes and all the like. It shows you more details, right? The number of core extents. Now, okay, someone gives us a new task, right? Someone gives us a new task, 3-M. Remember swap, right? You remember swap? Swap is 4 gigs. Someone say we should add another 1 gig to swap using the volume group VG data. But when we do VGS right here, this is not up to a gig. This is not up to a gig. So what should we do? We need to add a physical disk right here. It should now, the system might see it as SDC. They will initialize that SDC into a physical disk. And what we will do is we will grow the volume group so that the volume group will now we'll extend the volume group with the new physical disk that we've added. So that means 2 PVs now. That will mean that 2 PVs, SDB and SDC, all of them will be giving their space to this volume group, right? Now let's go quickly and add it. Let's go quickly and add it, right? So I edit my settings on your on your virtual box. You can add also more than one. I add a new storage hard disk. I add this one to be maybe 5 gigabyte. And let me make a thin provision. Make sure I make it a thin provision. And okay. Now, as you can see, if I do LSBLK right here, you can see that there's now SDC. That's 5 gigs. And it has no logical volumes and all the like, right? Remember, we've added this. We've added SDC. You can still just start following here and going. Now the system, we can see it on the system. Now let's turn it into a physical volume. PV create /dev /SDC, which is our new disk. If we do PVS now, we can see that. What can we see? Can you guys describe what you're seeing? Resize to FS works also for XFS file system. I think resize to FS does not work for XFS file systems because I've tried it. I think it did not work. But it's been long, like 4 years ago. I don't know. I think something is staying in my brain. Yes, I tried it. XFS underscore grow FS. Resize to FS is only on real on ext4 file system. Okay. Now, can you guys describe what you're seeing here? Can someone, yeah. /dev/sdc has no VG, right? It's free. It has no VG. Whereas these other physical disks, they have all their VGs. They all belong to like VGs. Now we want to attach a second one to this. So I just say VG extend. Since the VG group already exists, I just say VG extend. What am I extending? VG data. I'm extending VG data with /dev/what? /dev/sdc. As simple as that. That's all you need. It says successfully extended. If I do VGS again now, you see, there's 5.11 gigs that I've added. Before there was none. Now I have now more space to create new LVs. Now, because they said I should create something and add it as swap and extend the swap to 5 gig. I want to create a new LV logical volume. I do an LV create, LV swap, LV swap, because the other one is swap. Let me just create D swap so that we should know that LD swap, so that we should know that it's coming from VG data. LD swap, right? Create LD swap. Okay. -N -L -L. Let me do VG display to see the number of extents first. Now I want to use extents instead. Let me do VG display to see how much the extents are. VG display. Okay, there are 4. So what are extents? Extents are the way so let me say data is being organized into blocks. Just think of a store or a warehouse, right? Where clothes, some of you have seen pallets of clothes that they ship to different countries. They are in blocks, right? They are in blocks. So that's how data is being stored also. Data is being stored in blocks. So data, you can decide that your data should be stored in blocks of 4 megabytes, or you can store in blocks of what? 8 megabytes or 16 megabytes. Or you can store data also in blocks of 15. It's just like you go to the store also and you buy gear. There are things of what? There are crates of what? 12. There's a crate of 12. There's what we call a 6-pack. So it's storing that thing in groups of 6. Now, data is being stored in groups. So if you calculate 48 gigs, 48 gigs gives what? 12,393 extents. If it's storing it in groups of 4, it will give this total of groups of 4s. If it was 8 megabyte here, what we'll see here is 2. The total number of extents will be 2 because it will be 4 megabytes 2 times. Is it understood? What I'm explaining, do you guys understand? Let me explain again. Data is being stored in groups of 4. Yes, Jocelyn, watch. Data is being stored in groups of 4, right? in groups of 4. Now, how many 4s would give you 48 gigs? If you calculate it, it will give you almost this amount right here. What? Jocelyn, you said 12? 48 gigs is 48,000 megabytes. So 4 megabytes, it will be 48,000. If you want to do the calculation, take it on 48,000. So 1 gig will be how many extents? Let me see math. Let me see your math stuff. 1 gig will be how many extents? Hello? 1 gig will be how many extents? Hey, you guys don't know. 250. This sounds like come for a cat. Mil. Yeah. Because if you're storing something, if they give you $1,000 and they tell you to store it in groups of 4, you divide it to 4 people, you give them what? 250, right? So that's what we call extent. Data is being stored in groups. Now you can choose to store in groups of 4 megabytes. Right. It will be 256. I know. I know. Yeah. Keep it simple for people to understand. Keep it simple for people to understand. It's 1024. Right. Now you can see why this thing is 1024, right? Okay, that's it. It will give you 256. Some of you have seen maybe bought memory cards of 2. If you, in those days, they used to sell us memory cards of 256 megabytes. You'll be so happy having a memory card of 256 meg. Right, so that's what extents are. Now, since you know what extents are now, we wanted to create our LV. Let's not forget that we wanted to do this. We wanted to create our LV. Okay, let me clear my screen. Now, LV create what? The name is LD swap. That's L. If we want it to be 2 gig, 2 GB, how many extents will that be? Yes, Jocelyn. Type. How many extents will that be? Don't take calculator. On te donne 2000 divisé ça par 4. Tu prends la calculatrice. 500 extents. It will be 500 extents. So LV extend dash L500. Oh, LV create, sorry, dash L500. The space is coming from VG data. VG data, right here. LV created. Now let's do LVS. You see? Well, it rounded down. That's fine, but that's fine. It rounded down to like 1.95 gigs, 1.95. So it did a round down. If I wanted to do the 1024 stops and the like, it will have given me almost the exact space. Yeah, not exactly, but around. You see, 500 G will give you like 1.95, which is right here. 500 extents, the number of extents right here. Right. So now We just have to make our file system, right? At this point, they said swap. What is swap? You guys should explain what is swap to us. What is swap? Okay, good. Some people said memory. Great. So remember we said swap is disk, but it's not part of the file system. Since it's not part of the file system, we don't want to make it turn it into a file system because we don't want to mount it anywhere. We want to mount it as swap. So how do you do a make swap, right? You do a make swap. Make swap /dev mapper what VG data. This is the complete path /dev mapper VG data this. Make swap /dev mapper VG data LDS swap. Great. It says setting up swap space version 1 size 2 GB. I've set out space, and this is the UUID of the swap that I've set. You see, but if we do free-m right here, we still see this, right? We still see that. We still see that. It's still 4 gigs that it was, right? But we can see the UUID. If we do swap on -s, which is show me what is giving this 4 GB of swap. It tells me that it is /dev dm1 that's giving this 4 GB of swap. Now, if I do swap on, right? Swap on, sorry, -va, right? -va, V is just for verbose. So if you do -a, I just want to do -v also. /dev what? /dev, the VG name is VG data, and the LV name is LD swap. I want to turn it on. I want to turn this on to swap. Since I've already made it swap, I've already done a make swap /dev this. I make swap right here. Great. It tells me that I am turning this to swap. So it says this swap is already active. I would have done this without the A even. A just means all. This swap is already active. I ignored it. Now, I found a new swap signature, which is /dev mapper VG data. Swap on /dev this. I'm turning it on. If I do free-m again, free-m, you can see that the swap is now what? 6 GB. If we do swap on, that show. Now, how many things are giving swap? 2. Can you see this? The other one is given 4 gigs, and the other one is given 2 gigs. Now, this is only temporal. It's only temporal. Everything that is not in FS tab, when it comes to storage, is temporal. If I reboot the system, this swap will be gone. So I need to go into FS tab and put it inside. Right? VI to slash etc FS tab. Oh, I do BL kit or BL kit to see my swap space. I think I should see it somewhere here. Right here. /dev mapper VG data LD swap right here. And I can see my swap space right here. Type swap. VI to slash etc FS tab. And Shift G takes me to the last line or add a new line. And I say UUID equals to, I paste the UUID. Did I mount it on anything? No, I mounted call swap. And what was the file system type? The file system type also was swap. I can just do my default here, although you can do priorities, but that's for another day. Default, what? 0, 0. That's it. And if I do swap off /dev dm3, which is this swap. If I do, let me clear my screen. So I did a swap off /dev this. And if I do swap on dash show, now it's only one again. If I do a mount dash A, I don't know if it's a mount the swap, mount dash A. And if I do a swap on dash show, no, you need to actually do a swap on dash A. Swap on dash A. And it mounts it automatically because it is in HCFS tab. We good? Questions? Questions? What I said is you don't mount swap on the file system. That's what I said. You don't mount swap on like the system's file system, because swap is actually, it has a different mechanism, right? It's being used differently. When I did a mount dash A, did you see it work? No. When I did a mount that dash A here and do a swap show, it wasn't mounted, right? You could not see the swap coming on when I did a mount command, right? When I did a swap on dash A, activate all swap that you see, all swap space that you see, even the one that is in SCFS tab. It says, okay, I have activated it. And when I do a swap on dash S, you can see it here. Questions? Yes, ask your question. Can we also share the swap together server to other server? No. How will you share swap to other server? The swap is being used by at a lower level of the system. How do you want to share that? No question means I don't understand. Oh, it means you've understood. Oh, you go over it. Which one? Which one? Okay. So, well, you can give me now, if I face a scenario where you give me 20 gigs, for example, let me add another gigs, which is 20. You give me 20 gigs and say create 3 things with it. Oh, you give me 20 gigs and ask me to use it to create different things, right? Maybe the swap space that I have to create is not of LVM type of swap. Maybe it's I have to use the traditional method or the basic method. We call it basic storage. Edit settings. Let me add a 20 gigs here. 20G. In provision. Okay. Great. I've added another disk in here. You see, if I do LSBLK now, you'll see my 4th disk, which is SDD right here. SDB is mounted here. SDC is mounted here. But SDD, now let's take this scenario. With SDD, someone has asked me to create a VG app, a volume group for the app, which is like 15 gigs, and create basic storage. Let me say, they say I should create a basic storage of equals to 1 or 2G, 2 gigs, right? Create another basic storage for swap. Let my swap be basic storage, not logical volume. Swap of 2 gigs, 2 gigs of swap. Then you create a logical volume, of what? 15 gigs. And with all this, what they do is they give me 120 gigs. This is where your FDIX now becomes back important. With all this, I am given 1 gig, 1 disk, which is 20G. How do I solve this problem right here? I've been given 1 gig, which is 1 disk, which is 20 gigabyte. And they asked me to do 2 basic storage and 1 LVM. This is where I'll use now my FDIX to subdivide my disk into 3, which one will be here, one will be here, and one will be used for this. With that, I'll just do fdisk -L to see all. I know it's already SDD. So I'll just go down here and see my SDD, which is 20 gigabyte. If I do LSBLK, I'll see it also. LSBLK, I see it, right? That's my 20 gigs that I've been given. So I do fdisk /dev/SDD, sorry, it's SDD. Enter. I enter inside here. I want to partition it. I want to partition it into 3 different parts, right? Now, I can press M for help to see everything. I showed you this last week already. I can see all the different options. To create a partition is new. N for new. New. N. I say new. Oh, let me go out back. Quit. Let me do it up here. All right. N for new. If I don't want to write anything yet, it's just like Vim. I quit and go out. But let me get in again. Let me quit and go out, clear my screen so that will be at the top. All right, new. Primary partition. I press P for primary. Yes. The first, you see, I want to create the first one right here. One. The first one. It starts from the first sector. I just do default. Enter. I just enter here and do default. Now it says size plus or minus plus this. I can just say plus what? The first one should be 2G plus 2G. I enter. It says created a partition size 1 for type partition 1 of type Linux and of size this. Well, yeah, let me keep it as Linux right here. But this one should be swap. The type of partition here should be swap. So I can just make swap and mount it directly. Now, if I do P for print the partitions, you can see that SDD1 is right here, which is 2 gigs. If I do new again, let me save and go out, but I can just do new again. Let me write and go out. So because if I do new again, it will come down and you will not see. Okay, good. It has created it. If I do LSBLK, you guys can see that there's SDB1. Let me clear my screen and do it again. You guys can see that there's SDB1, which is 2 gigs, right? If I call my fdisk command again, you'll say welcome. I do new primary. It already knows that 1 has been taken. You see, it gives me 2 because it knows 1 has been taken. I just say enter, default. It chooses 2. The first sector, I just do default. It knows where it stopped the other time. Then, how much do I want on this one? Plus 2 gigs, plus 2G. Now, this one has to be type swap. I don't know how to set it. What do I do? See. Okay. Oh, I just entered it. I wanted to show you before entering it. Partition number 102. So T means I want to modify it. I want to modify the partition. I wanted to show you, but I already entered. T means I want to modify partition 2. I want to modify partition 2 because this one, the type should be swapped, right? I do partition number 2. It says, do you know the code? O, you press dash L to list all. I press dash L to list all. It shows me that these are all the codes. If you want swap, you should enter number 82, right? 82 is swap right here, Linux swap, 82. So I just entered here, 82. You can see, but I entered 82. I enter. It says, okay, Linux change type of partition to Linux, from Linux to Linux swap. Can you guys see this one? Let me bring it up a little bit. Can you guys see it? I changed partition to Linux swap. You guys can see it now, right? Okay, let me bring it back up. Okay, you guys can see it now. Change partition to Linux swap. Now, if I do P for print, you see, it shows me clearly that there are 2 partitions, /dev SDB1 and /dev SDB2, which is Linux swap. I can create the third one. I just do new again. P for primary. It knows that 1 and 2 are already taken. It gives me 3. I say, okay, I enter default. First sector, default. What do you want? I want plus what? Plus 15. Plus 15G on this one. Yes, it says I've created the size. I do P for print. I see the size. It's Linux, but I want Linux LVM because I want to use this one LVM. So I use T to enter to modify the type. Which one do you want to modify from 1 to 3? I can see 3 partitions. I want to modify the third one. Do you know what you want, or I should list all? Well, list all. I want to see what you have. LVM is 8E. So I put 8E right here. Enter. It says change from Linux to Linux LVM. If I do print again, I can see down that I have Linux swap. I have Linux LVM as type. What do? I write it and quit. Just write and enter. You press write and enter. If I do LSBLK right now, you can see that we have SDD1, SDD2, SDD3. I've divided my disk successfully into 3, right? I can make the second one swap by just doing make swap /dev/ SDB2. Hey, it's SDD, sorry. SDD2. It says, great, I've created the swap. And this is the UUID. I copy the UUID, I VI into /HCFS tab in here. And I come down here. I write UUID equals to, paste the UUID. The type is swap. How many seconds did it take me to modify swap at work? Then you say work is difficult. What's difficult about it? It's done. And I do a swap on. If I do a free-m here, you can see that the swap is 6 gigs. But if I do swap on -AV, it says great. I ignore 2 of them that are already active, but I found a new one, which is SDD2. So I added it. So if I do free-m now, swap should be 8 gigs right there, 8 gigabyte. Now I've done this one. I can turn this one to an ext4 file system. I can turn this one. I can make this one, make FS, this one. Basic storage, you just do it this way. It's easy. Make fs.ext4. Make fs.ext4. What? /dev/sdd1. It's sdd1, right? This one was sdd1. It has created it already. Now, I make directory what? /what? Class. Can make directory /class. Then I mount what? Amount /dev/sdd sdd1 to /class. It's mounted to a df-ht. It's right there, but this is temporal. So I just copy this. There are 2 ways of mounting UUID, or you copy the stuff. VI to /HCFS tab. FS tab in here. Shift G takes me down, or at a new line. I paste this right here. It doubled it. And it's mounted on what? On /class. The file system type is what? ext4. And I do default and 0, 0. I save and quit. I mount it to test it if my FS tab is working. I'll mount /class. It's unmounted. Then I do a mount -a. Mount everything. Then I do df-ht. It should be there. If I mount it again, mount /class. df-ht. You see it's gone, right? It's not more there. But if I do a mount -a, this tells me that whenever my df-ht, it's right there /class. Is that understood? Now I have one SDD3. If I do LSBLK, I can see all of them here, right? I have SDD3, which I can use it. I can use it for any, I can turn it to a physical volume. If I do VGS, you can see that I have VGREL and VGData although it is not like recommended to grow the file system, like the root file system, but let's try to grow the root file system with this 15 gig. df-ht, since it's already existing, the root file system is already existing. This is it. /dev matpar rel root, which is what? 20 gigs, sorry, 45 gigs. 20 gigs is free. It's 56% used. Well, let's turn this into a physical volume and use it to extend the rel volume group. Then use it to extend the logical volume. Clear. If I do PVS, VGS, LVS, I'm just naming all the three things. The first one right here, PV. You can see this PV. You don't see anything like SDD. The volume group side, which you see here, PV, VG, LV. The volume group sides, I have two volume groups, rel and this. Rel has no space left, and this one has space left, right? The LVs, I have LV swap, I have root swap, LD swap, NFS, right there. Those are my LVs. I can now do a PV create with /dev/sdd3. If I do lsblk now, you can see that SDD3 is right here. SDD3 is right here, which is 15 gigabyte. If I do PVS, you can see that SD3 does not have any volume group. What should we do? Should we extend or we should create a new volume group? We just extend. LV extend, LV extend, what's the volume group? The volume group is called rel. And we want to extend it with /dev/sdd3. Sorry. Oh, sorry, VG extend, not LV. VG extend. Okay, now if we do VGS now, this one has 15 gigs free. Rel now has 15 gigs free. Now if we do LVS, our system had what? 44 gigs. Remember, you said when we are extending, how should we extend? We should extend using what? We should extend and extend with this thing, but I think there's another option, which is -r, which extends and you don't need to do xfs_grow_fs. Now, if I do LV extend rel, LV extend rel, LV extend, sorry, LV extend -l, what? -l, let me give how many gigs? Let me give like 14G. Let me give 14G. But remember, you must put a plus, right? Plus 14G. -r means just do it recursively. -r means do it recursively. I don't want to go doing SFS_grow_fs again. Please just do it for me. -r this. So I'm extending /dev rel root. It says insufficient free space. Let me see. Extents needed, but only 389 available. Oh, I did 15 gigs. Okay, let me do 14. Because, well, rounding up is, forget about the round up. Even in the exams, they'll tell you, don't mind with the round ups. We know that rounding up is a little bit, it's something that you should not concentrate on. Right. You see, now it did everything for me in the fly. I don't need to do SFS_grow_fs anymore because of this -r. Now, if I do a df-ht right here, you can see now that /root has come down to 43%. It's now grown to what? 59 gigs. Before, it was not 59 gigs. Now it's grown to 59 gigs. And now, if I do PVS, you can see that this one also is contributing to the real what? Volume group. If I do LSBLK, you can see that SDD is going here. SDD2 is swap. SDD1 is mounted to class. And that we took 20 gigs, divided it into 3, and share it within the system. Is that understood? Okay. And this will take us to the end of what we did today with LVMs. It's been such a ride, huh? All right, let me stop the live.